Hi dear, today we'll see some numericals to find the position, nature and size of the image, okay, and the reflection of lights, okay. So you remember this mirror formula and as well as the magnification, right? Mirror formula is what? 1 by f equals to 1 by v plus 1 by u, right? Magnification is height of the image by height of the object. It can also be given in terms of distance of the image and object also. So magnification equals to minus v by u. The mirror formula also you can give it in the form of in terms of r, that is 1 by f can be written f equals to what, 2r, sorry, f equals to r by 2, so 1 by f can be written as 2 by r, so 2 by r equals to 1 by v plus 1 by u. Okay, see, we'll see a convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. If the bus is located at 5 meter from this mirror, find the position and nature and size of the image formed. So what is given? So rear view means what? Backside view. So what is happening in the backside you can see through this mirror, okay. So for that they use the convex mirror, okay. So what is given? Convex mirror is given is convex mirror. The radius of curvature is 3 meter. Radius of curvature is 3 means f equals to r by 2, that is focal length equals to r by 2, that is equals to 3 by 2 meter. Then if the bus is located at 5 meter from this mirror, that is your object location, that is u equals to, always it present in the left side of the x-axis, that is x-axis, negative side of the x-axis, right? So minus 5 meter, okay. First we'll using the ray diagram we'll get a rough idea how what is the position of the image, how the nature, what will be the nature of the image, how the size of the image will be, okay. So convex mirror means what? It curved outwards, right? Curved outwards. This is a non-reflecting side, this is a reflecting side. So this is a principal axis and this is your pole, and here the center will be here, and this might be your f, right? This is your f focal length, and your object is the radius of curvature, it is a distance of 3 meter, they said 3 meter. The object is located at 5 meter from the mirror, so 5 meter, take for example here the object is placed here. So the object is placed in front of the mirror, that is between the pole and the infinity, okay. So if the object is placed between the pole and the infinity means where you will get the image as per the rule of convex mirror. As per the rule of the convex mirror, you will get the image. Where you will be getting the image? It will be somewhere between the pole and the focus. You will get the image. Do you remember this? You will get a image like this. That is, this is the object. This will strike the object. It's parallel to this means it is parallel to this means what? Then it appears to converge from focus, right? It appears to converge in focus, right? We have studied, right? It will reflect like this, right? It will appear to converge here. It will appear to converge here, and this is a ray which passed through the center of curvature, right? Center of curvature, when it passed through the center of curvature, it will be reflected back again. So which is a meeting point of these two things? So this is a meeting point of these two things. This your image will be formed here. So what is the position? Position is behind the mirror, which lies between pole and the focal length. What is the nature? It is virtual. It is, since it is behind, it is virtual and erect image. What will be the size of the image? It is slightly diminished, okay. So this is the rough calculation, right? So you'll get the image behind the mirror, and it is small in size, and it is erect and virtual in nature. Okay, so we'll we'll now, using the mirror formula, we'll get the exact value. Okay, so we need to find the value of v. This is your v, image distance from the pole, v. Okay, we need to find the nature of the image, size of the image, nothing but the height of the image. Okay. Okay, so this u, v and f are related to the formula. You know that 1 by, excuse me, mirror formula, 1 by f equals to 1 by v plus 1 by u. You need to find only v, so keep it here. So this 1 by u will move to this side, so 1 by v, and this is plus, so when move to this side it becomes minus 1 by u. Okay, so substitute the value. What is 1 by f? F is equals to 3 by 2, so 1 by f means 2 by 3. 2 by 3 minus 1 by u. U value is minus 5. Right? Substitute it. Solve this. So need to subtract this, right? Subtract this fraction. So what you are supposed to do? So the denominator should be same, right? So what is the LCM of 3 and 5? So 3 and 5 is 15 only. So here you have to multiply it by 5. So here also you have to multiply by 5. Okay, to make this thing positive, denominator positive, we are going to multiply it by minus 3. Here you are going to multiply by minus 3. Now here also you have to multiply by minus 3. Okay, so what is so your denominator become 10 by 15 minus 3 by 15. So your denominator become equal, right? So now solve this. That is equals to common denominator. This is 10 minus 3 into minus 3 plus 3. So plus 3. That is equals to 13 by 15. This is what? 1 by v equals to 13 by 15. Therefore v equals to 15 by 13. Okay, so it is positive. Positive means what? It will lie in the positive side of the x-axis. So your answer is correct. So it lies in the positive side of the x-axis. We have to check whether it is lies between p and f. We'll do the division. 15 by 3 is what? 1 time 13, 2, so 0, 20 again, 1 time this 13, and 10, 7. Again if you put 0 like this, it will go, right? 0, 13 time means around 5. 5 times 5 3s are 15, 5 balance 1, 5 ones are 5 plus 1 6. Okay, we'll put 5 times 5 3s are 15, 5 balance 1, 5 ones are 5, 6, 65. So it will go like this. So you subtract this, you will get 5. So it will go like this. So that is equals to plus 1.15 meter. So definitely it is positive, so it lies behind the mirror, the positive side of the x-axis. Okay, so your answer is this v is correct. Okay, next so you found the v, right? Next what you have to find what is the nature of the image. What is the nature of the image? You have to find it by magnification. M equals to you are having this v value as well as this u value, no? So you can use this formula, minus v by u, that is equals to minus 1.15 by, what is u value? Minus 5. That is equals to what? 1.15 by 5. This is your numerator is smaller, right? So denominator is bigger. So definitely you will get the value less than m will be less than 1, right? Your m will be less than 1. How much it will come? do this 1.15 divided by 5, 0 times 0, 1, bring this 1, so 11 means 2 times 10, 1, again 15 means 3 times, so 15. Okay, so it comes out to 0 plus 0.23. So your m is less than 1. This implies your image will be what? We have learned that when m is less than 1, then it is your image will be small in size when compared to the object, small in size. Okay, it lies in the small in size which is erect also. Okay, small in size which is erect also. So how next we have to find the size of the image. Size of the image means what? You now found the magnification, right? M equals to h dash by h, right? H dash by h. What is your you need to find this h dash, right? So multiply this, therefore h dash equals to m into h, that is equal to 0.23 into what is the h value? The size of the image, h value is h dash equals to 0.23 into h, but you don't know the you don't know the size of the object, so we cannot go by this method, but we are having one more method to find this. What is it? You know that magnifications equals to h dash by h, that is equals to, you can write the magnification in terms of v and u also, right? V and u. So you can now you can compute from this, right? So your h dash equals to okay. Here also we need the h value, so we can give the height of the image in terms of this factor itself. So that is h dash equals to 0.223 times of h, 23 times of h. Okay, definitely if it is multiplied by a decimal point less than 1, then we will give the diminished image, the size of the image is small. Okay, this much, that means 0.23 times of h. Your image will be 0.23 times of the image of the height of the object. Okay, so your answers are v equals to what? V equals to plus 1.15 meter. Next, nature of the image will be small in size, which is erect. Small in size, virtual and erect. Okay, how much small it is? 0.23 times small. Okay, 0.23 times of the height of the object. Okay, next, the next question. Object 4 centimeter in size, that means they are given the height of the object, is placed at 25 centimeter in front of the concave mirror of focal length 15. At what distance from the mirror should be placed in order to obtain the sharp image? Find the nature and size of the image. So first, using the ray diagram, we will come to a conclusion how the image will be position, nature and size, everything. Okay, so what is given? You are given as your concave mirror, height of the object is 4 centimeter, your u, that is position of the object is minus 25 centimeter, always it is negative, and focal length is given as 15 centimeter. So since it is a concave mirror, you curved inwards, and this is your non-reflecting side. So this is your pole, this is your F, and this is your C, center of curvature, right? So this is negative side of the x-axis, so minus 15, F is minus 15 means radius of curvature will be 30. Okay. Next, the object is placed, this is the radius of curvature is 30 means, then they said object is placed at a distance of 25 centimeter. 25 centimeter somewhere it lies between here, like when the object is placed in between C and F. Okay, this is 25 centimeter from the pole. Okay, if the object is placed in between C and F means, you know that you will get a what? You will get a image, a real, you will get the image beyond the C, which is real and inverted, and it is enlarged in shape. Do you remember that? So it will strike this, and when the lines parallel to the principal axis, it will pass through the what is this? Focus point, right? Focus point. One more ray we can pass through this. When it is passed through the principal focus, to focus point, it will be reflected. It will be reflected back, right? Parallel to the principal axis. So the meeting point of this is here. So you will get the enlarged, real and inverted image here. Okay, clear on this? So you will get the enlarged, real, inverted image. Okay, now we will find the exact value for where is the position of this image, and what is the size of the image also. Okay, using the mirror formula and magnification. Okay, so we know that we have to find the V value, H dash value and nature of the image also. So we know that using the mirror formula, 1 by F equals to 1 by V plus 1 by U. So you need to find the value of V, keep it here, and this U will move to this side, so it's become negative. 1 by F minus 1 by U. So what is F value? It is 15, minus 15. So 1 by minus 15 minus 1 by U. U value is minus 25. Substitute this and find this. So what is the LCM of 15 and 25? In the last previous term, we have seen that the LCM of 15 and 25 is 75, right? 75. So here you have to multiply by 5, right? Here 5. To make it to positive, you have to multiply by minus 5. Here also minus 5, minus 1 by minus 25. 25 into 3 will give 75. Here also minus 3. So minus 3, that is equals to minus 5 by 75 minus 5 by 75 minus 3 by 75, right? So you can solve this here. So that is equals to 1 by V equals to minus 5 by 75 minus 3 by 75. That is equals to 75 common denominator. So now you can separate minus 5 minus into minus 3, it is plus 3. That is equals to minus 2 by 75. So 1 by V equals to minus 2 by 75. Therefore V equals to 75 by 2. Minus 75 by 2, that is equals to how many times? Minus 3 times here, balance 1. 15 means 7 times, then balance 1, it becomes 10, 5 times. So 37.5 centimeter negative. This shows that V is in the negative side of the x-axis. Exactly. So this is the center of curvature lies at the distance of 30. So you know that the image will fall beyond the C. Okay. So you come. It is 37 point beyond the C. It is. This is here, somewhere here, 37.5 centimeter. Okay, clear on this? Okay, next. So we need to find the nature of the image also, right? Magnification. M equals to minus V by U, that is equals to minus of minus 37.5 by U is your u is minus 25, right? So you will get if you simplify this, you will get minus minus get cancel, again you will get one minus. This is how much? 5 times here, minus minus. Okay, this one 5, this will comes to 7 times balance 125, 2 times 25, 7.5. again we can simplify, it becomes 1, this become 1 point balance 2 25 1.5. okay, so you will get minus 1.5. okay, this is your magnification. M equals to minus 1.5, which is equals to, we need to find the height of the image also, right? H dash by H, you know the if you want H dash, cross multiply this. What is the value of H here? H is minus 1.5 equals to H dash by H. What is H? Is your 4 centimeters. So if we cross multiply this, minus 1.5 into 4, that is equals to H dash. Minus 1.1 15 into 4 is what? 60. So 1 decimal point place minus. So minus 6 equals to H dash. Minus 6, it shows that your image is inverted in the downward side, right? Downward side. It is when what is the height of the height of the object is 4 only, but what is the height of the image? You got 6. So it shows that your image will be real because it is fall in front of the mirror. So it is real, inverted, since it got minus 6, it is inverted and enlarged in size. okay, clear on this? So your v is your minus 37.5, that is, it lies in the negative side of the x-axis. Nature of the image will be real, inverted and enlarged in size. okay, what is the size of the image? Size of the image is 6 centimeter. okay, negative, it shows that this it is in the downward side. okay, inverted, right? And your last sum. okay, object of 5 centimeter in length is placed at a distance of 20 centimeter in front of convex mirror. okay, of radius of curvature 30 centimeter. Find the position of the image, its nature and its size. Same question, same type of question. So convex mirror is curved inward, outwards. First draw the rough diagram. An object is 5 centimeter in length is placed at a distance of, for example, 20 centimeter in front of the convex mirror. Object is placed here somewhere between infinity and the pole. Then you know that you will get the this radius of curvature is 30 centimeter. This is 30 centimeter. So your f will be here. Definitely you will get the image here, right? In between pole and f, and the size of the image will also be diminished, smaller in size. okay, so we'll check we'll get the exact value, what is the height of the image and what is the size of the image and all. Using the formula we can get the exact value. okay, so how you even you can draw the ray diagram. So it is appears to converge through the focus, so it will reflect like this. okay, next if another line pass through the center of the curvature, both the line meet at this point, this is the image. okay, and this is your v. okay, so you know that you are given with the height of the image, distance of the object and radius of the curvature. From the radius of the curvature we found that f equals to 15 centimeter. We need to find value of v, nature of the image and size of the image also. okay, so you know the mirror formula, you can substitute this. 1 by f. Why f is positive here? Because it lies behind the mirror, which is positive side of the x-axis, right? So 1 by 15 and 20. What is the LCM of 15 and 20? 15 and 20. So 5, 3, 4, 3, 1, 4, 2, 2, right? By 3s are 15, 15 2s are 30, 30 2s are 60. Okay, 60 is your LCM. So by which number it has to be multiplied? 15. 15 into 4 is your 60 minus 1 by minus 20. 20 into 3 will give 60. Here you have to multiply by minus 3 to cancel this negative term. Okay, so here also you have to multiply by minus 3. So 1 by 60. Sorry, here also you have to multiply by, here multiplying by 4 means numerator also you have to multiply by 4. So 4 by 60 minus 3 by 60, that is equals to, the denominator became common, so 4 minus into minus plus 3, that is equals to 7 by 60. 7 by 60. 1 by v equals to 7 by 60, therefore v equals to 60 by 7. Okay, so it is positive. What is this value? It is 60, 7, 7 8s are 56, 8 times 56, 4, 40, again point, if you place the point, 20, 35, 7 5s are 35, again it is 5, so it goes like this. Okay, so you can take this as, that is equals to 8.5 centimeter. So v value has come in positive, so it lies in the positive side of the x-axis behind the mirror, and also 8.5 centimeter from the pole, right? So it lies between, your focal length distance is 15 only. Okay, so it lies between focal, 8.5 lies between focal point and the pole. Okay, so we found the phi, which are v value. Now we'll find the what's the nature of the image. Okay, so you know this object height, so magnification equals to h dash by h, right? That is equals to minus v by u. If you want this h dash value, h dash equals to h dash equals to minus, what is the value of v? 8.5 by u value is minus 20 into, what is your height? Height is 5. So definitely you will get a positive value only. So if we cancel this, it become 4, right? 4. So h, if you cancel again, becomes 8.5 by 4, which is equals to 2.1, again becomes 10, 2 times, so 2.12 like this. So your image, your height of the image is 2.12 centimeter. Okay, so you know that your height of the object is 5 centimeter. So your height of the image is 2.1 centimeters. Show that it is diminished, smaller in size. So what is the nature of the image? So nature of the image is, since it falls behind the mirror, it is virtual h dash, you got it as a positive, so it is erect, it lies above the x axis. Okay, erect, and since the size of the image is small, it is smaller in size. Virtual, erect, and smaller in size. Okay, clear on this? Thank you.